In this video, we're going to take a look at graphs of functions. Before we do any specific graphing, we're going to talk about the difference between the domain and range. So domain are the set of values of the independent variable. Another way of referring to those values is that they are the input values. More specifically, they're the x values. And then by contrast, the range is the set of values of the dependent variable corresponding to all the values of the independent variable in that domain. Another way they're sometimes referred to, those dependent variables are referred to as the output values, or more specifically the y values. Now, this particular lesson for day 5 has 2 videos and 2 note sheets that go with it. So if you want, you could stop this video right now and go watch the other video, video number 2, that's associated with day 5, because that will give you a little bit of practice on looking at graphs and determining what the domain and range values are and writing those out. If you choose not to pause the video right now, after you finish watching this one, make sure you watch the second video. Both of them are important and contain important concepts that you need to learn. All right, now what we're going to do in the remaining video lesson here is that we're going to take 2 specific equations and we're going to graph them, and then we're going to identify the range associated with them. When you do your graphing, I tell my students, look at the equation first and identify what the general shape of that graph is going to be before you ever start. And then look at the domain that you've been given. If you've been given any restrictions, that will tie into what x values you pick. If you haven't been given any restrictions on what the domain values should be, then you can pick anything, but sometimes it's wiser to pick some values than others. So if we take a look at this very first equation, we've got a parabola, all right? And more specifically, and we've got a parabola because the x value is squared. And more specifically, we've got a parabola that opens down because the leading coefficient is negative. So in general, our graph is going to look like that. Now, you notice that we have a decimal in that original equation that was given to us. Sometimes it is better to think about these in terms of their fraction equivalents. And the main reason I say that is because you should be graphing this without a calculator. And so sometimes when we look at it with the fraction equivalent of the decimal value, it will help us pick a little more wisely what x values we pick. Notice we have a domain of all real numbers. So theoretically, we could pick anything, but it might be easier to pick some values that would work out more nicely with that -2/5 and help us have some integer values that we can actually graph. As far as how many points you need to plot, we ask for at least 3 points, but I will tell my students that when we're graphing parabolas, 5 is even better. So the easiest x value, in my opinion, to pick would be to pick an x value of 0. And if you plug a 0 into our equation and you square it and you multiply it by -2/5, you still get 0. All right, and then some students may say, well, you know what, 1 is pretty easy to plug in. You're right, 1 is pretty easy to plug in. So if we plug in a 1 into our simplified equation here, and again, I'm going off of this equation. That's the one I usually look at. But if we plug a 1 in for that x value and we square it and we multiply it by -2/5, we're going to get -2/5. And another easy value then to plug in would be -1, because if we square it, we get a +1 and multiply it by -2/5, and we get -2/5. So even though I encourage you to pick 5 values, you can be smart about how you pick those values and you don't have quite as much work. All right, then as far as another value to pick, if it were me, I think I would try to pick something that's a reasonable value for x, such that when I simplify it, it would, or such that when I calculate it, it would simplify with that 5 in the denominator. So let's say we plug in a 5 for x. All right, if we plug in a 5 into our equation here and we square it, we get 25. And then if we take -2/5 times 25, we're going to get -10. And then if we plug in a negative 5 for x and we square it, we still get 25, and we multiply it by negative 2/5, and we get negative 10 as well. So you can pretty easily and quickly get 5 values to plot. Now, I believe my grid does not have 10. I think it only goes up to, what, maybe 8? 1, 2, 3, 4, 5, 6, 7, 8. So sorry about that. So keep in mind, I'll scale my y values by 2 so that I can fit these on here. And I ask my students that if you're going to scale by something other than ones, you know, you just need to let me know. So maybe put a little 2 right there, so I know that you're scaling by 2s. But negative, and I'll scale my x values still by 1. So if I do negative 5, negative 10, it's going to be right there. Hopefully I'm counting correctly as I'm doing this. Negative 1, negative 2/5, I'm going to say is right there. 0, 0 here. 1, negative 2/5 right here. And then 5, negative 10 is going to be, let's see, 1, 2, 3, 4, 5. All right, I believe right there. I apologize. When I'm doing these videos, if I happen to miscount, I apologize. All right, and then a parabola should be more U-shaped than a V. V is absolute value. It should be more U-shaped. So when you're drawing your parabolas in, make them more U-shaped. All right, now as far as the range goes, that's where the practice from the other worksheet comes in. But if you look, I've got arrows on the end here. So I don't have a lower value for my y, but the highest value that my y is ever going to be at 0. So I'm going to have, for a range, y is less than or equal to 0. Okay, for our second example, we have y equals x minus 2, which hopefully we know that that's a linear equation. So when I graph it, I'm going to have a line. I could even take a look at the slope, since it happens to be in the slope-intercept form, and know that the slope is positive. So, you know, I'm going to have a line slanting to the right, so to speak. I am given a restricted domain. So when I go to pick my x values, I need to think about what that restricted domain tells me. So if I have non-negative integers, all right, non-negative, all right, probably the biggest thing for debate is going to be, is 0 going to be included or is it not? Because we know obviously negative 1, negative 2, negative 3, those are all literally negative, so we're not going to include those, and we know that 1, 2, 3, etc., those are positive. So we would include those, but the thing is are we going to include 0 or not? So is 0 a non-negative integer? If I were in class, I would be asking you for feedback on what you think about that. But 0 is neither negative nor positive. Okay, it is neither negative nor positive. So it is non-negative. All right, so that's going to be the first thing that I plug in. All right, and I'm going to plug in a 0 for x and get, you know, negative 2, and then I would just pick a few more. When I graph lines, I usually only pick 3 values for x. Yes, I know you can graph a line with only 2 points, but we usually ask you for 3, so we'll do 3 here. So if you plug in a 1 for x, you get negative 1. If you plug in a 2 for x, you get 0. And yes, it could keep going, which we'll talk about in just a moment. So when we plot these points, we've got 0, negative 2, we've got 1, negative 1, and we've got 2, 0. Now, again, if we were in class, I would be asking you the following questions. Okay, what are we going to do from there? And very frequently, I will get the response that we should draw something, you know, that looks like this. All right, and I say, well, you know, I like the fact that you're just focusing on the non-negative values. That's great. But if we take a look at that, since that is a connected graph, so to speak, it's array specifically, but if it's a connected graph, we are accounting for values of x that are not integers. So if you think about it, like right in here, right in there. Whatever that x value is, that is not an integer. Or you pick something, in between 3 and 4 right here. Whatever that x value is that's associated with that, that is not an integer. So by doing that, we've misrepresented what that domain restriction is giving to us. So if we go back here, then some students will say, well, I'm not sure what I'm going to do after that. So here's the thing. We need to have just distinct points plotted for this graph, but we certainly know we have a lot more non-negative integers for x than the ones I just plotted. I just picked 0, 1, and 2 for x. There are many, many, many more non-negative integers. In fact, there's an infinite number of them. So what I ask you to do is plot at least 3 points, because that kind of establishes the pattern. And then I typically tell and if you want to do more, you could plot another one. But then I just ask my students to do something like this. And that just shows to me, and I notice I didn't do a solid line and connected it, but to me that shows that the pattern keeps going in that fashion. It doesn't just have 3 points that I'm going to plot, or 2 points that I'm going to plot, or 4 points that I'm going to plot, or even 10 points I'm going to plot. It has an infinite number, but it keeps going in that pattern. If that's a question that you have tomorrow, make sure that you ask your teacher about that. All right, then as far as the range goes, if you look at it, our lowest value for our range, for our y value, is -2, and then anything beyond that. So again, we need to say y is greater than or equal to -2, but then there's one additional component that we need to add to it. When I say y is greater than or equal to -2, that means that I could have a value of -1.5. Well, if you look at the graph, I don't have a y value of -1.5. It means I could have a y value of, 3/4. I do not have a y value of 3/4. If you look, I'm only going to have integer values. The smallest one I'm going to have is -2, but then it keeps going higher from there. But each one of those y values must be an integer. So we can just write a note, for instance, and y must be an integer. Now, there are all different ways mathematically we could write that, but in the cases that you're going to come across, if that's the way you want to express it, just with a little quick comment like that, I'm fine with that. Again, if you want to check in with your teacher and make sure that she's okay with that, certainly feel free to do that when you're back in class tomorrow. Thanks.